industrial coating. So the main reasons behind automating a paint booth really are labor shortage, the work quality, or it could be productivity or the worker safety. So we're going to be addressing all those different subjects today. And my topics are going to be the currently available technologies, their capacities and limits, and how to evaluate your needs. My guest, Pierre, what will be your subjects today?
Well, we'll be, first of all, introducing our company, Evo-Tech Industrial Coating. We'll talk about manufacturing process, different paints requirements, and the market trends.
Okay, so stay tuned till the end. Since it's our first time in English, we will be having a draw of a participation prize at the end. So make sure you stay with us until the end. And while we set up for my part, we will be showing you a quick information video on how you can ask questions throughout the webinar. Thank you. All right, so let's start with the available technologies at JSA Machinerie. First of all, we do have the flow coating technology. So it could be either horizontal or vertical. These are addressed for, it's a specialty for wood treatment. You could be working with furnitures, windows, doors, or any wood structures. So it's basically flow coating is a treatment shower of the product that you're going to put on your wood surface. It's a very minimal technology where there's no parameters such as thickness of product or the amount of product that you're going to be putting on your material. It's really you're just passing your parts through a shower. So I'm not going to address too much of this technology today, as we want to cut to the more of the robot lines, but just know that it's technologies that we have available for you. The main difference between horizontal and vertical is that when you're looking at a vertical system, it's a system that's going to be able to be automate. So we're going to be able to put those parts on a chain of production, where if you're looking at a more of a horizontal system, you're going to be looking at more of a manual entry, manual exit of your parts. So really no automation solutions there other than just the part is being painted by itself as it's being trained into the machine. The second solution that exists we would call the Cartesian robot. So it is not yet what we see as a robot, like the arm moving around. It really is more of a robot that's built on a Z-axis, so making some movement from up and down. So you have a nozzle of paint this time, not as the flow coating where it's more of a product that you're going to be using for wood. This is more addressed for painting, but again, it's not as accurate as either a human or a 6-axis robot. So these technologies would be used more for primer coating of doors, or primer coating of any wood structures if you're thinking about prefab walls and things like that. Again, not going to go so much deeper into that. What you see on the picture on the screen right now, you're seeing some jams being receiving a primer coat. So you can see on the left of the screen, you see the nozzle there. It's really making a movement from up and down. No parameters again on the quantity of paint that's being used. It doesn't really matter if there's little drops or things like that. So it's not a very precise work, but it can be, again, automate as a chain of production. So it's really gaining time there in your production. Now, let's cut to the anthropomorphic robots. Much easier to say 6-axis robots. So I'm going to use the 6-axis for the rest of it. So 6-axis robots is really what you're thinking of when you're thinking about an industrial robot. So it's really the arm that moves around and recreates the human work. Very flexible and agile. And what we're going to be looking at is really at a level of repetition of your work. Very uniform work, and what you're going to see day one is what you're going to see 5 years down the line. It's always going to be the same quality that you're going to be driving out of your robot. Again, now the most important part of the technology is not the robot itself. It really is all driven by the software behind the robot. And this is where the company we distribute, Furniture, has put all their effort at creating the best software out there to help you with your work. So what I'm going to do to explain the best I can is take you on a journey of a part throughout the layout. So first thing first, if you're looking at the left end of the screen, you're going to be looking at this a charge and so load and unload part. This is where your employee is going to be sitting. He's going to be loading the parts there on the machine, and using a barcode reader, he's going to read a barcode to tell the machine exactly what to do. Part is then going to make his way through a scanner. Here's a picture of a scanner. So the scanner is working with 2 different technologies. It's working with infrared system, and it's also working with laser system. Sorry. Just going to explain to you exactly how this works. So the infrared system is going to be giving you the length of the part and its position in space. So what I mean by position in space, if the part would be hooked this way on the hooks, the machine would know, it would tell the robot to where to go and where to paint. Where the laser are going to be taking parts if the part is crooked this way or this way. So it's really the combination of the laser and the infrared are going to give you like a 3D modeling of the part that's being painted. So if I'm going back to the first stage, you're going to be scanning a barcode. The barcode is only going to be given the information of what product is being painted. So let's if we're talking with the window industry, let's say I have a 4.5 frame and I want it black. So this is going to be the information that's going to be on the barcode itself. There's not going to be any length, any size of the window that's going to be involved in it. It's really going to be just a matter of giving the color and giving the robot the what he has to do, what program he has to do. So the next part, if I'm going back to the layout there, So there's where you see on the bottom of the screen and just about in the middle, you're going to see what we call like a buffer zone. So this buffer zone, parts have been scanned. The information is entered for size-wise in the machine, but it's kind of just a buffer zone where, for example, if your regular shift has a break in the morning of about half an hour. Well, if you're loading that buffer zone, the line is going to keep on going while your employees are taking their break. So again, it's a good idea to have one. It's not mandatory. The layouts could be drawn any different ways, but just for the example, we did put one that had one. So again, just a buffer zone, nothing is happening there except parts resting. Then the next part, the part is going to enter the painting booth itself. So as you can see on the layout, the part is going to enter in front of the robot. At this point, as soon as the part enters, the robot starts his work. So the robot is going to be controlling the speed of the part that goes in front of him. So what I mean by that is that the part is not going to be stopping in front of the robot. If it can keep on moving to avoid losing time, it's going to keep on moving. But the robot has the power of stopping the part if he feels like he needs to. So let's say we have a huge window to be painted. We're going to be, the robot is going to tell the line to stop. The good thing about how Finisher designed their line is that there's a two-rail system on the machine. So it kind of if you do skiing, if you're thinking about the chairlift getting at the bottom of the hill, slowing down for someone to sit down, and then you're looking at the rest of the chairlifts, they're moving at the same rate. It's because it's a dual speed, dual rail system. So the robot is using the same technology to slow down the part in front of him, and the rest of the line just keeps going at the same pace, so you're not losing any time there. Next part is going to be the drying area. Are you working with ambient air? Are you working with oven? Are you working with infrared? All technologies that are available. I don't believe there's any good or bad solutions there. It really depends on the product you're painting and the paint you're using and how fast you want the parts to be out of the system and things like that. So it's all topics that could be addressed, but just know that all the technologies are available to put in there. It's just a common paint booth such as all the other ones at this point. I want to bring your attention to the top, just middle of the screen now. You're gonna see that the parts are kind of shifting sideways. So again, we're using a double rail, but this time instead of changing speed, it's just the parts that are moving sideways. So you can see that the buffer zone, the resting area, can have a lot more parts than if they were just one behind the other and staying on a single rail there. So again, not a huge technology, but it's something that you're really gaining a lot of space in your factory. I've said it before, those layouts can be adapted to all of your needs. There is not a one solution fits all. It's really, we're gonna go to your factory, see what you have to do, see how you're doing things, and then draw a layout from there. This one is just an example, an easy example of what can be done. Important part, if you are using many different colors, such as pretty much every company is out there, you probably have black is your biggest color, but once in a while you have to paint some windows green or pink for any reason. know that the robot has a solution of cleaning itself in between every single racks that comes in the paint zone. So even though you would be painting black all day, the nozzle would be clean in after every racks or of windows that comes in front of it. So make sure that we don't have any dust or anything that builds up on the end of the nozzle and have some bad work to be done on it. So just a short video of how it's done. You're seeing here that the robot is painting, making its way around the window, and then going to be clean as what you don't see there is the parts are actually moving out of the paint booth, and the next windows are coming in at the same time. So it's really working in the downtime. It's not working. It's not adding any time, any manufacturing time to your process. Another thing is pump stations. So you can see on this picture here many different pumps. Usually what we try to do with customers is address the biggest cells colors. So again, if I'm thinking about Canada, you're probably going to have one pump that's going to be black, maybe one pump that's going to be commercial brown, and then you're going to be looking at a custom color pump. What we try to do is have two different pumps for that would be the custom colors. So you're not rushing to be changing your color every single time there's a new color. If you have two of them, you can switch in between them. And you're going to have a last pump that's going to be the water pump, where it just helps you drain the color as you're switching colors. Keep in mind, again, if you want 20 pumps for 20 different colors, it's just a matter of knowing when we start the project on how many pumps do you want. There's no right or wrong answers towards that. But the only thing with pumps that we're going to be telling you is we're going to be telling you what size of pumps that you should buy. But again, we're not the pump sellers. You work with the company you're used to work with. We're just going to be addressing the size of them to make sure that the robot doesn't miss paint during the work. All right, so capacity and limits. The first of all, the one big subjects that we have with customers is can this be working with solvent paint or water-based? So my answer is the only difference is going to be the price. If you're going to be working with solvent paint, you're going to have the system to be explosion proof. So you're going to be adding somewhere around $100,000 for the system to be explosion proof. Other than that, this whole debate about solvent or water based, you're going to have with Pierre or your paint provider. It doesn't really change anything at the level of the robots. Very important details that needs to be addressed when we're building a quote for you is the temperature. So is it hot, is it cold, is it humid, or is it dry in your factory? And obviously in Canada, one day is hot, one day is cold. We have all those different temperatures. So there's such things as air conditioning or machines that are going to play with the humidity level in your factory, especially in the paint booth itself. Those are things that we're going to be addressing with you to make sure that we give the paint all the chances it can have to be drying at the good pace that's indicated by the paint company. I talked about racks before. You can see on this picture right now, you see the racks. those racks could be 2 meters, 2.5 meters, 3 meters, 3.5, and 4 meters wide. There is no limits of how many parts you can put on one rack. The best example I can give you would be you're painting one window that's one frame and two sashes. Obviously, it's going to be the same color, so you're going to be able to fit all three parts on the same rack. The only thing that you're going to be looking at is make sure that you have enough space in between all parts for the robot to be able to do his work. If you're kind of painting on the side of it, so make sure that you overflow all the contour of your window. Then next is the capacity of the robots. There is 3 available robots that we work with. The first one would be the small one. It's 3 meter by 2.8 meter. We haven't sold any systems with that because windows are tempting to be bigger and bigger right now. If you're looking into a much larger capacity, there's another robot that has a capacity of 4 meters by 2.5 meter, or we can change with the same robot having 3.4 by 3 meters capacity. If ever you think that this is not enough, just know that the robot can always be installed on a 7th axis. As you can see on the picture here, this exact project was done in Europe. It's 20 meters long rail, so there is really no limits to the size you can have for that 7th axis. So this was done for a company that builds pre-built walls, just to give you an example of what can be done. All right, now, most important part, how to evaluate your needs. Biggest questions I get every single time I'm going to a customer that wants to automate his paint booth is, can I add a robot in my existing room? The answer is not that easy. I'm not going to say no, but I'm not going to say yes. So here are the things you need to address if you want to keep your existing booth. So first of all, the part needs to be capable of moving. So it needs to, if we're going back to the layout there, it's going through a scanner that measures the part. So if your painting booth does not have a chain, it doesn't make any sense for the way our system works. Second thing, that scanner, again, it needs room. So if your paint booth has a chain, but there's no room to install the scanner, again, we're going to be facing a problem because this part needs to be measured in the scanner. Third thing would be, if I'm going back again to the layout, monorail. So if most of the chains that exist right now on the market are on a monorail system. So first of all, you're not going to be able to do the dual speed like I talked about in front of the robot. So let's say you're stopping your part in front of the robot, and the rest of the line is going to be stopped. And the second thing is the resting area where you're not moving, you're not shifting windows sideways to accumulate them, then you're going to be facing a problem in space. But again, that's not no or no go for the robot itself. It's just to keep in mind that the robot is not going to be optimized if we're always slowing down the chain. The part must be stable as possible. So a good system of hooks would be needed to be in place. Simon, la pièce. So if I'm going through the scanner this way, and as I'm moving, the part shifts this way, well, it's not going to be painted because the robot waits for it this way. So you need a system that's going to be holding the part throughout the whole system the same way you've put it on. After that, maximum sizes. just keep in mind that the robot needs 600 millimeters on the ground below the part to be able to do his work eventually. So most of the rails systems I've seen are much lower. So the parts are really moving like very close to the ground, and it's usually the painter that bends his knees and goes under it. Well, the robot doesn't have any knees, so it's not going to be able to go there for you. And keep in mind that you have the rack, you have the rail system, and your biggest window, so it gives you quite an important height to be respected. Last part would be security. It is not a collaborating robot, so it needs to be caged. There's no employees that can be next to the robot while it's moving. Otherwise, it's not going to be there. There's a security fences that will stop the robot. So what I've seen on paint booths is that there is not enough space to add the robot, but not enough space to add the security around it. So again, it's something that stops the projects there to modify an existing room. Now, the creation of a new booth or modification of a previous or modification of one, if all previous points were respected, the information that we really need from you guys is one, the maximum size of parts that you want to paint. This is going to give us the rack size. This is going to be giving us the size of the booth itself that we're going to be creating. And it's going to give us a lot of information on how to first start the drawing of the booth itself. The second thing would be a 3D plan and pictures of the surrounding. Why am I asking it a 3D plan? Is because we're building a building into your building. Okay, that's a lot of building, but we need to know what's above the ground and not only work with the 2D two-dimension drawing, because we need to know like how much height do we have in all of the surrounding. Why pictures is many times I've seen plans from a factory that were missing a post, that were missing a window on the wall, and things like that, that could be something very bad when we're installing and not realizing that we had something in our way there, something we don't want to happen again. Third thing that you need to know, need to give us is how many parts do we have to paint in our shift. It's going to be addressing how many racks we have on the line, obviously the size of the paint booth itself. Another thing is the parts drawing. Are we painting window frames? Are we painting doors? Are we painting chairs, for instance? So we need to know what we're painting. So obviously at the beginning, to have all of the drawings really help with the planning of the layout that we're going to be doing. And how many colors, we've addressed that for the number of pumps, and trying to know as much as possible of the use of those colors, because many times people are coming to us saying, hey, I have 45 different colors, but really we're only using 2 at 90% of the time, and all the 43 others are just once in a while. So it's going to change the pattern of how we're designing your line. Just keep in mind, those projects can be done in 2 phases, where we could be, first of all, building the paint booth itself, and on the second phase, adding the robot. That would be a way to be splitting the cost just about half and half. So this is going to be done for me. If you have any questions that came in, okay, so we don't have any questions. All right. So I'm going to be leaving you guys with a quick time lapse of the last installation we did of a paint booth while Pierre is setting up for his presentation.
Good morning. First of all, I'd like to thank Martin and JSA Machinerie for inviting us today for this webinar and have the opportunity of meeting all of you today. So let's first of all talk about the table of content. Table of content, we'll be introducing Evo-Tech, and then we'll be talking about the manufacturing process as well as the paint requirements, which I split my topic into AAMA standards as well as surface preparation requirements for different substrates. Then we'll be followed by trends and a question period. Brief history about Evo-Tech. Evo-Tech was founded in 1965. It was the former division of Seco Industrial Paint. And it first of all got involved into the manufacturing of paint for residential door and window market 25 years ago. Then we started to produce two types of systems, water-based system and a solvent-based system. The water-based system is at 35-degree glass, and the solvent-based system is at 45-degree glass. To support that market, we have an R&D department that will analyze our systems, analyze customer needs, as well as define new products and define quality control guidelines to make sure that the products that we have are meeting the different criteria. Our manufacturing process are being done at the Cornwall plant. And this obviously is a 60,000 square foot plant, where we manufacture solvent-based as well as water-based system for all our customer needs. The manufacturing process starts with raw material picking and weighting. Then we go to the dispersion phase, which is followed then by a sand mill or grinding process, followed by finishing and packaging. In the raw material division, we are handling two types of raw material, powder form as well as liquid forms. When we mix those two products, we generate a paste, which is then being processed at the dispersion area. On this slide, you can see different disperser that we have in our manufacturing plant. Disperser we utilize varies from the size of the vessel that we utilize for mixing our paste. So we have mixing vessel that have a capacity of 60 gallons to 600 gallons per batch. On this slide, for instance, we're showing the 600-gallon disperser that we're using. After having the paste dispersed, it goes to the sand mill area. The sand mill per se on this slide, you could see, is like a columns. And in that column, we have like grinding medias where we force pump the paste from the bottom to the top, so that by doing that, we can generate the homogeneous paste, homogeneous color in terms of pigment, as well as making sure that the pigment size is properly grind so that it won't block any spray equipment. When the grind size is finally obtained, QC'd, we go to the finishing area where we're adding up the rest of the raw material to adjust the viscosity, adjust the color, and making sure that it meets the customer criteria. Without the quality control department, this won't be possible to be done. On this slide, on the left side, you'll see that this is a piece of equipment that we're using to analyze the grind, but we're using different pieces of equipment to characterize the product so that it meets customer needs. One, obviously, test that we're doing is color verification, and we're using the LEB system. So for those of you that don't know too much about LEB system, it's a universal system that we utilize to numerically characterize the color. On this slide, you see that the L axis will define the darkness or lightness of the color, and the A and B coordinates will define the color, whether it be green, red, blue, or magenta. Then, when we have the color numerically in our system, we could compare it to a standard. In a lot of documentation that you will see, we're talking about delta E measurements. In our case, we're using a little cousin of the delta E characterization, which is called the DECMC, because the DECMC is more appropriate to define the color, because that is closer to what the human eyes can see. And in our laboratory, we accept a color variation of 0.5 on DECMC. In a lot of literature, specifically with AAMA, for instance, you will read that certain tests requires that the DE should not be more than 5 in terms of color variation. I wanted to show you on this slide what is what does it correspond for delta E of 5 in the same shape, obviously, of green. You could see here the difference of the delta E of 5 for a green. Then we also test heat buildup. What is heat buildup? Basically, it's a way of measuring or predicting how your PVC extrusion will react to sun exposure. The heat buildup test is based on ASTM D4803, and it compares basically the reaction of your PVC extrusion with your paint compared to a black control sample. So basically, the apparatus that you have here is an open box with isolated styrofoam. On the floor of that box, you have a temperature probe where you're going to be placing your PVC sample, and that PVC sample will be submitted to an IR lamp that you have on the top. And normally, the test is done under a 30-minute exposure of the IR lamp. You will be measuring the temperature at that time, and then we will compare it to different standards. So on the next slide, the delta T that you obtain from the ambient temperature and the exposure after 30 minutes has been computed in the equation, the 11.2 equation that you see on that slide. And basically, if you were to use the black control sample, at that time, you will end up having a measurement of 41 degrees Celsius for a vertical exposure and 50 degrees Celsius for a horizontal exposure. In our case, the quality control maximum temperature that we're accepting is 32 degrees Celsius. So basically, what does that mean? That means that if you were to, for instance, utilize a product or a paint your PVC extrusion, and you have a delta T that is, let's say, give you a 40 degrees Celsius, and you're at a 30 degree Celsius ambient temperature, that means that your PVC extrusion needs to withstand 70 degrees Celsius exposure. So we know that in our trade, for instance, most of the PVC that are on the market right now will be able to withstand temperature around 60, 65. So the next slide I wanted to show you is an example of heat buildup measurement that we could get if we compare a white PVC at the top of the table on an horizontal position. You're going to get 24.9 degrees Celsius, whereby if you go on a black, which is at the bottom of that table, you will end up at 25.7 degrees Celsius. We do that for all the colors as well as all the bases that will be used to make any shades of colors. Then when all the tests are being done, it goes to packaging, the packaging area, and ready to be shipped to the customers. On top of that, next slide, please. As we said earlier, the customers are asking for a lot of just-in-time custom colors. So by using our service center and the colorimetry system, using a spectrophotometer, we could generate just-in-time custom colors. Spectrophotometer, for those of you that are not familiar with that, are the equipment that we're using to measure the colors, and you've got a representation of that spectrophotometer on the front, on the center of that slide. Paint requirements. Well, I mean, again, as I said, I split the topics in two. Well, first of all, talk about AAMA standards. So we have AAMA standards have been split by substrate. So we have standards for PVC, fiberglass, and aluminum. They're most likely look alike each other, except obviously the substrate differs. So we'll be talking today just on the 26O series because it will be almost the same for all the substrate. So what I did is I prepared a table to show you the differences in terms of requirements depending on if you're looking at 2603, 04, or 05 standards. For surface prep requirements, you could see here on this slide that the AAMA standards are a little bit, I'd say, not so precise for 2603, whereby 2604 and 2605 are requesting proper amount of chromate to be deposited on the substrate prior to the application of the paint. Then, if we look at paint film requirements, it varies from a minimum of 20 microns to 30 microns, depending on the standards that you're looking for. And if you look at also the film hardness, strangely, the different standards are asking for a harder film, which is a H minimum for 2603, against 2604 and 2605, which are requiring a F minimum, which is softer hardness of film than the 2603. On adhesion requirements, mainly all three standards are almost alike. They're asking for no failure on dry and wet adhesion, as well as impact resistance. It differs a bit on 2604 and 2605 for boiling water and abrasion resistant, which are a little bit more stringent requirement for 04 and 05 for AAMA. Next slide. Chemical requirements. Again, all three standards are asking for the same thing for resistance against muriatic acid or mortar resistance. And it varies a bit for nitric acid because in this case, only 2604 and 05 are requesting resistance to nitric acid with a delta E of maximum 5 after 30 minutes of exposure. Next. Humidity and salt spray resistant. This is probably where we could see the differences between 2603, 04, and 05. In these case, the resistance or the tests require 1,500 hours to 4,000 hour exposure, depending on the standard that you're looking for, whether it be under the humidity chamber or the salt spray salt spray cabinets. On the weathering, there's only an accelerated test exposure for 2603, and where it really differs is the outdoor exposure, where a 1-year exposure South Florida is requested for 2603, and 04 and 05 are respectively at 5 years and 10 years with a maximum DE of 5 again, and also some requirements in terms of, I would say, gloss retention. Then the next requirements are surface preparation. We're dealing with 6 different substrates when we're in the residential market: PVC, polypropylene, pre-painted steel, pre-painted aluminum, bare aluminum, and fiberglass. So let's talk about the different surface prep requirements. Next slide, please. We first of all have to deal with PVC, so a simple cleanup with acetone is required. That is required to remove any deleterious substances, as well as lower the surface tension of the PVC so that the paint is wetting properly the substrate. For polypropylene, it's a little bit more complex. We have to first of all clean up the surface with acetone, then use an adhesion promoter like our 360-051 with a very fine mist coat, then let it flash off before application of the top coat. For pre-painted steel or any pre-painted metal surface, I've put a warning on this slide because it's very, very important that first of all, you have to check out the compatibility of the pre-paint coat against the top coat prior to do any big work, because there are some pre-painted coating that are not compatible with your top coat. So the process when you've checked that then is to clean up the surface, scuff the surface, and make sure that you don't remove all the pre-paint coat from the surface. Otherwise, you're going to have to reprime the surface prior to the application of the top coat. After scuffing, obviously, clean again and top coat. On pre-painted aluminum, same remarks that I did before. Make sure that you have a good compatibility of your pre-paint coat against the top coat. Clean up the surface, scuff the surface, make sure again that you don't remove all the pre-paint coating before the application of your top coat, and then top coat the surface. On bare aluminum, it's a little bit more complex. You have to first of all sand the surface and clean that surface before the application of a vinyl wash primer, such as our 360s or 535. And you have to apply a mist coat of that product, allow it to dry a bit, but the application of the top coat should be done between 5 minutes to 4 hours after the application of the vinyl wash primer. Otherwise, you're going to have to start again the process to prepare your surface. Fiberglass, very easy. You've got to clean the surface, cup the surface. Make sure that you remove also any type of water repellent that could have been applied by the manufacturer, especially the ones that are shipping products from abroad, because these products are being utilized to avoid having any fiberglass warping. So you have to remove that before top coating the surface. As mentioned earlier, we have like 2 systems, ACRYTHANE AQUA SERIE 528, which is our water-based system, and ACRYTHANE 3000 SERIE 592, which is our solvent-based system. Both systems have excellent adhesion to PVC, fiberglass, pre-painted steel, or aluminum, and they come in 29 standard Gentech color. We have also a system for staining and ACRYTHANE AQUA. Both systems have a low heat buildup characteristic, and they have a proven track record of 20 years. About manufacturing trends, there are trends for manufacturing and trends for final customer. These are two different ways of looking at trends. On the manufacturing side, obviously, the most important thing is to improve productivity. If we think or talk about paint installation, obviously, we have 3 steps: surface preparation, paint application, and lint drying. So surface preparation, there are many ways to automatize I would say, mechanical adhesion, which is scuffing or sanding. Although the minute that you have to talk about solvent application, it's done manually, because the system that would be needed to do that would require explosion-proof requirement, and it's too costly for the trend we are right now. Paint application, I think again, I'm not going to talk too much about that, because Martin had already done a good job on that. On the end lint side, there are various ways to do it, from air frost dry to IR drying, which will improve productivity. Then on the customer trends, we have to talk about colors. Martin had already started to talk about that. In Canada, black is very popular, but we have also some trends on wood appearance, where people are trying to do or give wood appearance on fiberglass as well as on PVC. Then finally, I'm just going to give you the most popular color that we see right now in the market, which are black, iron ore, commercial brown, slate, pebbles, or chestnut brown. So this is finalizing my presentation, and thank you again for your time. And if there is any question, I'm open to answer all of your questions. Thank you.
All right, thank you very much, everyone, for joining. Thank you very much, Pierre, to taking part of this. This was a kind of a first experience for us, so Pierre was diving into the unknown with us. Thank you very much for your participation. Like I said in the beginning, since it's our first experience, we decided to go with a little price. So we got you guys, got one of you guys, some earplugs. Pierre, will you do the honors? Taking one name down there.
Okay.
We have Sebastian Jan from Coltech. Congratulations. We'll be reaching out to you for your price and shipping it to you. I believe I have 2 questions that came in, so we're going to address those before ending this.
The first question is from Mike. What's the estimated capital cost for a complete system?
For a complete system, if you're, Mike, I'm not sure if you're in Canada or USA right now, but if I'm talking in Canadian dollars, you're going to be around somewhere $700,000 for a complete line. If you're splitting that in half, like I mentioned before, you could do the paint booth itself and the robot. It's going to be just around that level of price. Obviously, depending on the project, we could state that you need 2 robots for some reason or things like that. Well, it obviously would change the price, but you're going to be in that area for pricing.
And the second question is from Mercedes. Can we paint wood?
Yes, it's feasible. Yes, of course. There's only a wood primer then to be utilized prior to the application of the paint, but there is no problem to paint wood.
All right, so that ends it for question and for our webinar. I would like to invite you to our next webinar is going to be October 14th, and my guest is going to be Mathieu Hébert. He's going to be with us to talk about hardware trends, codes, and things like that. On my parts, I will be talking about the automation of a pass-through line, pre-drilling of hardware, and going through that subject for you guys. So October 14th, 11 a.m. same time is going to be our next appointment. We will be reaching out to you guys in the next few days to see if you have any questions on today's webinar. For my part, and Pierre will also be able to address all questions coming for paint. Once again, thank you very much.
Thank you.